As the global populations continue to increase, so too does the demand for food. With many people now adding types of seafood into their diets, there are large stressors on the natural supplies of seafood. Many countries have begun to use aquaculture farms to help supplement the increasing demand for seafood. Our presentation will look at the practice of freshwater aquaculture. It was created by
Cribbett,
Terry Fraser,
and Mccorquodale.
This is a brief overview of the topics we will cover in our presentation. We will begin with some information about aquaculture, the different types of aquaculture farming, some of the negative impacts caused by this type of practice, some possible alternatives, and then provide a conclusion. Aquaculture is the farming of aquatic organisms such as fish, shellfish, and even plants. These farms are found in many countries around the world. China has been using this practice for over 2,000 years, and the revenue created by these farms has become an important part of many cultures. In Canada alone, the aquaculture production was valued at $837.3 million. This was 30% of the total seafood production value. The industry employs more than 16,000 people in Canada, and there are aquaculture operations in each province and in the Yukon Territory. These operations produce over 70 cold water species, but salmon, trout, mussels, oysters, and clams dominate Canadian production. This industry is expected to keep growing. By 2020, the output could exceed 308,000 megatons and create revenues in excess of $1.5 billion.
The most common production unit in aquaculture is the pond. There are three basic types: embankment ponds, watershed ponds, and excavated ponds. Fertilizers may be added in ponds to increase the phytoplankton base of the food web and to allow greater production of the culture species. Feeds may be used to increase production above that possible with fertilizers. Aquaculture feeds are made from plant meal, fish meal, and other animal meals. Mineral supplements, vitamins, and other additives are added to the feeds. Ponds constructed in areas with highly leached, acidic soils have waters with low pH and low total alkalinity. Most aquaculture species grow best at pH 7 to 8.5, and total alkalinity should be above 50 milligrams per liter. Acidic pond waters are neutralized by treatment with agricultural limestone or other liming materials. Natural food organisms are scarce in cages and net pens, and manufactured feed is applied to enhance production. Soluble and suspended wastes are flushed from culture units by water movement. Larger waste particles settle beneath or near cages and on the bottom area enclosed by pens. The amount of cage and net pen culture in water bodies should be limited to avoid excessive eutrophication and periodic dissolved oxygen depletion. Water movement is very important for removing waste and restoring DO. Eutrophication does not develop in flowing water systems because of rapid water exchange. Inflowing water is the primary source of dissolved oxygen in unaerated systems, and the main loss of dissolved oxygen is by fish respiration. High stocking density is permissible in flow-through units because the main factor limiting carrying capacity is availability of dissolved oxygen, not space. Fish can be grown under extremely crowded conditions provided water quality is good. Mechanical aeration may be applied to flow-through systems to increase dissolved oxygen availability, carrying capacity, and production. Solid wastes consisting of uneaten feeds and feces that accumulate in the bottom of flow-through culture units can be removed by suction devices or through drains in the bottom of units. In water reuse systems, water is passed through a pond or other water body for purification by natural, physical, chemical, and biological processes. and mechanical aeration may be applied to enhance waste treatment capacity. A very small portion of freshwater aquaculture production is from water reuse systems. There's much interest in these systems where they require less space, use less water, and discharge less pollution per unit of production than other grow-out methods. Their contribution to production will likely increase dramatically in the future with enhanced technology.
Although aquaculture farms are helping to alleviate some of the demand on natural stocks, there are many concerns about the negative impacts these farms could have on the environment and society. Most of the farming is done in fish nets in our lakes and oceans. The open nets allow the waste created by the species and the excess food to travel through the net and move directly into the receiving water body. The waste and the excess food contain high levels of nitrogen and phosphorus. High levels of these nutrients being released from the fish farms allows for the acceleration of lake eutrophication. With the increase in aquaculture, there has also been a rise in concerns about human health risks with eating farmed fish. There has been a number of pathogen outbreaks in aquaculture farms, and to battle those diseases, the farmers must use formulated feeds that contain antibiotics, antifungals, and agrochemicals. These additives can lead to high levels of antibiotics, antibiotic-resistant bacteria, persistent organic pollutants, metals, parasites, and viruses. Populations that are the highest risk of exposure are those living near aquaculture farms, individuals that consume the seafood, and the employees that work at the farms. At many aquaculture locations, there have been animal escapes through equipment failures and flooding events. These escapes can negatively affect the environment and the native species. The farmed fish may outcompete the native species for food and habitat. If this occurs, the native species populations will steadily decline. It has also been discovered that if the farmed fish do breed with the natural stock, these hybrids don't grow as quickly and could seriously suffer from temperature changes and their ability to fight diseases.
One of the alternatives I will be discussing is indoor recirculating aquaculture systems, also known as water reuse systems. These involve using large tanks to house the fish being grown instead of the more traditional practices of fish raceways or ponds within freshwater systems outdoors. These tanks can form a large amount of fish of different species within one building or plant. The recirculating aquaculture systems, or RAS, take much less water in the long term as compared to the more wasteful practice of freshwater raceways. The classic aquacultural practices can input large amounts of suspended solids and organic matter, not to mention leftover antibiotics and antifungal products into surrounding water bodies, leading to pollution and also potential cases of eutrophication. In recirculating aquaculture systems, fish are raised in tanks in high quantities. Fish are provided with proper temperature and dissolved oxygen levels that you would naturally see in the environment. Water is only added to compensate for evaporation and splash. Here are some of the risks associated with recirculating aquaculture systems. Since there is such a high number of fish within the tanks, if a disease were to be introduced to the population, it would rapidly spread throughout the fish and could cause catastrophic crop losses. Without proper monitoring, the computer system that monitors and maintains the conditions within the tank could malfunction and cause a loss of fish stock. Human error, like adding too little of feed, or also improper distribution of antibiotics, is also a large factor in the loss of fish crop.
Fish is an excellent source of animal protein and a wide range of essential nutrients. It contributes significantly to food security as well. 53% of the world's marine fishery resources are fully fished, or fished to the maximum sustainable level. Another 32% is overfished, depleted, or recovering from depletion. Since 1970, fish production from aquaculture has increased at an average annual rate of 6.6%. With production reaching 52.5 million tons in '08, aquaculture will soon overtake capture fisheries as a source of food fish. With the increase in demand for fish production and the growing awareness of environmental problems associated with aquaculture, new technologies and techniques can be used to utilize fish farming and make it more efficient and sustainable.